and materials. We already discussed density, now let's discuss pressure. Pressure, this is given by normal force per cross-sectional area. Pressure is defined as the normal force acting per unit cross-sectional area, which is force over area. Where force is measured in Newton and area is measured in meter square. So pressure is given by Newton per meter square. Now the unit of pressure is this, Newton per meter square, which are given the special name, Pascal. Pascal. So 1 Pascal is equal to 1 Newton per meter square. A question here. A chair stands on 4 feet, each of area 10 meters square. The chair weighs 80 Newton. Calculate the pressure it exerts on the floor. So first of all, we have to show that pressure is given by normal force per area. And the force is 80 Newton. Area, we have given that chair stands on 4 feet, each of area 10 meters square. So the total force will be 4 times 10, which is 40 meters square. So our pressure will be equal to 2 Newton per meter square. Thank you. Okay, now let us observe how pressure exerts in the fluid. We'll see how pressure depends on some factors in the fluid. For example, this is a water tank where water is inside like this, and this is the depth of container, and the area of container, let's say A, and the density of water is rho. Here our main objective is to look how or which factors pressure depends in the fluid. Okay, let us find the volume of water. Volume of water in this container will be given by area times depth. Area of container times depth of this container will give us volume. And also we have to find the mass of water. Mass of water is given by density times volume. Why density times volume? Because density is given by mass over volume. So now mass will be given by density times volume. Okay? Now, mass of water, because it is density times volume, it will be density, but volume of water is area times height, which is depth of tank, AH. So our mass is density times volume, which is area of tank, and depth of the tank. Now weight of water. Weight of water is mass times gravity. Mass times gravity, but our mass here is density times area times depth. So our weight will be equal to, our mass is density, area, depth, and gravity. But pressure is force over cross-sectional area. And now here our force is weight of water, which is density, area, depth, gravity over cross-sectional area. So this one will go with this one. So our pressure in fluids is density, depth, and gravity. So this is our popular formula for pressure in fluids. So finally, we say that pressure in a fluid depends on three factors, which is depth. This is how below the surface, depth below the surface, and the density of the fluid, and also the acceleration due to gravity. So pressure in the fluids will depend on these three factors, which is density, depth, and acceleration due to gravity. Thank you. So this is a question. Estimate the height of the atmosphere if atmospheric density at the Earth's surface is 1.29 kilogram per meter cube, and the atmospheric pressure is 101 kilopascal. So first of all, have to know that pressure depends on density, height, and acceleration due to gravity. And what we are required here is to estimate the height of the atmosphere. So now pressure is given, which is 101 kilopascal, and the density is given 1.29 kilogram per meter cube, and the height is not given. This is what we have to estimate. And acceleration due to gravity is 9.8. 9.8. So now we have to divide 1.29 kg times this one, this way 1.229 kg per meter cube times this one. So by dividing this, we'll get the height.